Okay, hello everyone. So we are going to start our chapter 2. The first topic in chapter 2 is designing a program. So let's start. Cool. So designing a program. For the program to be executed like in your computer, just making sure, yeah. For a program to be executed in your computer, it has to go through a certain process. That process or the execution of the steps is otherwise known as program development cycle. The first step is designing the program. That is where you'll analyze the type of parameters that you'll need. So for example, the program, let's consider this as a program. So the program could be just adding two numbers and then storing that added number into a different variable and then printing that variable. So that is our entire program. So when you look at this program in your head, you'll be thinking, so you'll need at least two variables to hold two digits or two numbers. And then you will need a third variable which will hold the result of these two operations. And then you will be printing that result or the third variable. So that is your design process. And then you will be taking in step-by-step process, right? So first from the top, you'll be first defining and then declaring the number, a variable, and then the second variable, performing the operation. Third is storing that result in a different variable, then printing that variable. So after this part is done, then you will be writing the code. So writing the code will have can be two different types. One can be a pseudo code, which is nothing but a fake code. And the other can be a code that is followed, that is written by following the syntax errors or the syntax of a particular programming language. So you will write that code and then you will execute the code. So at this stage, if your program is syntactically correct, then there are no syntax errors. Otherwise, the program is not converted into machine language for the computer to understand, because if it has syntax errors, then it won't be converted. So you will check for the syntax errors, correct the syntax errors, make sure that there are no more syntax errors, and then test the program again. So syntax errors and logic errors are different. So syntax errors is, let's say you have opened a brace and you did not close a brace. That is a syntax error. Logic error is, let's say I'm adding two numbers, 5 and 6, and the expected result is 11, right? But when a logic error occurs, the result could be anything other than 11. So maybe the result is 10. So the program is not throwing any syntax errors, but there are some logic errors, because it could be like the output is not the expected output, or it is trying to open a file which is existing in the folder, but it is not looking for the correct file. It could be anything. So those type of errors are called as logic errors. So the program development cycle will first start with the designing the program, writing the code, correcting the errors, testing the program, and then correcting the logic errors. So this is a repeat process. This is a loop process. So you will perform this until you have achieved your goal with respect to writing the program. So designing the program, as I've mentioned before, is the most important part of the program development cycle. So it is basically for the users or for the programmers to understand the task on what this program is supposed to do. So for example, here you are going to work with the customer to get a sense of what the program is supposed to do. So let's say I'm the customer and you're the programmer, and I am asking you to write a program that will add two numbers and then store this result in a different variable and print that variable. So you are going to get that sense from me. So you are going to ask how many variables, what type of data, like are those integers or are those floating point numbers, otherwise known as real numbers. So which type of data that I'm looking at. And then how do you want me to see the output? Do I just want to see the result itself, or do I also want to see a statement that says this or the sum of numbers a and b is c, or the statement that says the sum of 5 and 6 is 11, etc. So you will ask questions about the program details. That is what we have just discussed. So that is basically the specifications of how the output should be. And then if there are any more requirements with respect to software, then you'll also design that in this step. So the next is you will determine the steps that must be taken. So you will be breaking down the entire steps into a set of smaller defined steps. which is also known as algorithms. So algorithms are nothing but well-defined logical steps which are required for you to write a program. So when we spoke about writing the code, I did mention pseudocode, right, which is also a fake code. So this is informal language which does not require a syntax. So there are no syntax rules. So even if you like close a brace, open a brace, or then do not open a square, quotations and do not close the quotations, or if you do not even have the quotations for the string literals, that is also fine. And this is just used to model like the program itself. So this is not used as an execution file. You're not going to compile this or execute it. As you're not going to compile this, this is you do not need to worry about syntax errors. And then we have flowcharts. Flowcharts are, I'm hoping some of you are already familiar with flowcharts and what those are. So these are the diagrams which graphically represent the steps that needs to be performed in a program. So there are certain shapes and each shape has its own importance. So for example, here vowels are used as a terminal symbols. These are used for typically starting and then stopping the program, or start and end the program. Parallelograms are for input and output symbols. So parallelogram will have the variable that you are taking as an input and then the variable that you are taking that as an output. And rectangles are processing symbols. So from the previous example, like addition of two numbers, rectangles are the locations where you will find A or C is equal to A plus B. So whichever that you have with respect to the processing part, in our example, performing the addition is the processing part. So that is will be stored inside the rectangle. And symbols are connected by arrows to represent the flow of the program, which is again, like, from the name itself, it's a flow chart. So here is an example. First, you are starting it by using a nubble and then ending it by using a nubble. And here, after that, you have input the number of hours worked. So this is an example where you are calculating the pay of the user. So that is inside the parallelogram. Next, inside the parallelogram is hourly pay rate. Because when you want to, let's say, when you want to calculate the person's pay, you'll need to have two parameters, right? First is the number of hours worked, and then what is the hourly pay rate. Only with these two information, you can calculate the gross pay, which is nothing but number of hours worked multiplied by the hourly pay rate. That will give you the gross pay. So that multiplication is performed inside the rectangle, as that is the processing of this algorithm or of this program. And then you are displaying the gross pay, which is again by using parallelogram. And then you end the program. So I hope designing the program and the program development cycle are clear. So we'll talk about the next part in the next video.